This is third video of the series on shell and tube heat exchanger, and in this video I will explain the method to create the 5 tubes inside the shell and how to process these tubes from the shell side and as well as from these front and the rear header system, and as well through these two end plates. And for the clarity also I have given the side view. And in the side view, you can see that we have these 5 tubes. So this is not maybe the perfect configuration. And for perfect configuration, we have the square type of the configuration, triangular and inverted triangular, and inverted or rotated square configuration. So here purpose is that how to create them in the heat exchanger, and I will compare them while I will run these cases in the fluid. That is through the effect of the single tube and then on the 5 tubes. So what will happen with the heat transfer and as well as on the pressure drop, because pressure drop means that we need more pump work, that is the energy input we are giving, and the better transfer means that we are making the process complete within the given size of the heat exchanger. So these are two design constraints and they are opposing constraints. So we have to make the compromise between these two design variables here. So so just for this video or this series, the thing is that we want to compare two designs. One is when we have single pipe, that is the pipe in pipe heat exchanger, and then when we have the equivalent size of the tubes, and then we want to see that how this will affect heat transfer. And keep in mind that I didn't calculate the surface area of the single tube and these 5 tubes, but instead I proposed based on the design that we should go with the same cross section area which is we get in the single tube. So total we have the 5 designs, and the 5th design is basically they are if I tell you that there are the 5 designs in this way. The first design is pipe and pipe, and on the 2 sides there is no header system, but in the second design you can see that we have placed the 2 headers on the front and the rear side, and they will collect the liquid from the tube side. So one will be feeding the water in the hot water or maybe any fluid into tube, and second will collect that fluid from the tube, and then it will take it out to this side on left side. So this is the counter flow type of the heat exchanger. That is the one fluid will be moving in this direction and second fluid will be moving in this direction. So shell fluid will be moving in this direction and this will move in this direction. And the third design is the design when we have these tubes inside this heat exchanger instead of the single tube. And basically we started with the first video, then when we were talking about how to create these baffles, these 3 baffles, and subsequently we have created the 8 baffles basically, that is to follow the TEMA standards. And in the similar way, so for this design we have placed the baffles. So the only difference between this and this design here is that we have the baffles here, and similarly in this design the only difference is that there are baffles in this design. So basically there are the 3 the designs actually, and the 2 remaining designs which are design number 4, design number 5, they have the baffles instead of the simple tubes. So these are the basic dimensions for the first design, which is the pipe in pipe without any header system on both sides. And you can see the dimensions and the geometry making. They are the tube thickness and the shell side, shell inlet, shell outlet. The tube inlet is from the right side and this is a tube outlet. And here is design number 2 where we have added, only thing is that the length is even same, that is 360 millimeter for the tube and 300 millimeter for the shell side. And here the tube is truncated at the end of plate and the flow will go down in the header system, but design is same, that is the 25 plus 5 30, 30 plus 300 330, and same on the other side. So 360 total is the length of this whole design. And here is a AutoCAD drawing. So from here you can get the dimensions in a plan view very easily. And the third design is the same design, but we are replacing the single tube. And here we have the cross-section area of the single tube. And then for the single, if I divide them into 5, so I will divide this value by the 5, and I would get this area, this area. And then from here I can use the area formula. From area formula I can get diameter of the single tube, and then also on the same analysis also I can get the dimension, the diameter of the thickness of the single tube. So in the previous design there was the, in terms of diameter it was 13 and the 50 millimeter, but here is only 5.8, 6.7. There is only difference of the 0.9 millimeter. So on the both sides, that is the diameter we are talking about, is on the two sides. So on the one side this will be the even less. So 0.9 divided by 2 will be 0.45. So 0.45 on the each side. That was previously 1 millimeter on the each side. And design number 3, so it is continuing. So you can see the different views here of this shell and tube heat exchanger. And again I will reiterate that this is not a perfect design for the placement of the tube, but this will tell you the procedure and how to compare them from CFD point of view, also from the engineering design point of view. And again we have the drawings for this design, and this is design number 4, where we are adding baffles, and you can see that in the actual drawing how they will look like in the 3D model. And so we are placing these baffles, but these baffles are now changed into the 7 baffles. And so this is the drawing here. Okay. So now we'll start with the creation of this 5 tube shell and tube heat exchanger, and based on design number 2. That is when we have the header system plus we have the single tube. So I will replace the single tube into the 5 tubes. Alright, so this is the overall layout of the design number 3. And so as I discussed earlier that now these are dimensions for each of these 5 tubes, and also distance between these tubes is that in such a way that on the center we have the 1 tube, and then these tubes are placed on first on the 45 degrees from the x-axis, and then the subsequent 3 remaining tubes, they are placed at 90 degrees apart from each other. And the center of these tubes is at 11 millimeter from the center of the shell, and so it means that instead of having the halfway or midway, which is the 10 millimeter, we are making it at 11 millimeter. And also I would recommend that you can move this one up to even up to 30 millimeter to make it better for the heat transfer. But right now these are dimensions we will make in the Spaceclaim. And after applying these dimensions, we get the model in this way. And there are some tricks and techniques to create these 5 tubes instead of the 1 tube, which is very simple to create. So this will take some time, so stay with me. And at the end of this workshop, you should be able to get this geometry. And so start with the geometry here. And so I can right click on the geometry and duplicate, and I can put the name as practice design 3. So we are opening design number 2, that is the design over here, this design. And we will apply the process so that we can convert the 1 tube into 5 tubes. And here are the dimensions in 2-dimensional space. And so we start with the Spaceclaim. And first of all, hide the right plate, left plate, and as well as the thickness, and just keep the shell here. And also hide dimensions from the graphical user interface, and then from the design menu, click on the fill command, and select the internal surface of this tube, which is the face on the side of the shell. That side will be used as the interface. So there are the two surfaces, exactly same two surfaces. One is the part of the shell, second is the part of the tube, and they will make that is on the thickness of the tube. So this will make the interface between them. And just click on this OK sign, and this will simply remove this tube from the shell. And similarly, we have to remove the same thing from the other parts as well. And similarly for the left plate. And then in the pipe system. So in the pipe system, first of all, I'm going to create the one plane here, one plane on the other side. And I will use the combine command, and I will use this side here, and then again I will not delete the geometry right now, but I will be deleting I will split geometry on the other side also, so that we can only get the one single part here, which is the tube part, and we don't want to remove the geometry on the right or the left header, that is the front and the rear header. So now we are without the tube geometry here for all these parts, and also we can delete this whole part from here. And inside shell, then left plate, right plate, they are without any tube here. Okay, so again I will start with these two plates, which is the right and the left plate. And I will move this geometry, this plane slightly on the other side, so that we can create a sketch for these 5 tubes. And so for a time being, I will hide these geometry parts, which is the right and the left plate. And simply I will select this plane here, and I just want to make sure that this should not be inside any geometry here. So I will move this plane further from the whole geometry. So it should not be intersecting any of the main geometry here, so that these surfaces cannot form on their geometrical part. And now simply hide the left pipe system as well, and choose this pipe, this plane, and click on plane view, and then click on the sketch mode, and then start to sketch. And we start with the center tube, that is the diameter of 5.8, and also the other tube, they have the diameter of 5.8. So starting with the center tube, and diameter is 5.8 millimeter. Okay. And you can also confirm the dimension by applying dimension here. And second thing is that now we have to draw a line, and that line should make the angle of 45 degrees from the x-axis. And so we can assume this is the 45 degrees, or you can also, if you start from in this way. Okay, and to confirm it, you can apply again dimension, and from here you can see that the angle is 45 degrees. And second line would be at the 90 degrees from the first line, or from x-axis it would be the 135. And then again for the next line is a 135. And this last line, this is also again at the, this is going to be 90 degrees from this line. And to confirm it, we can apply dimensions here. And as you can see that the initial angle is 45 degrees, and then the subsequent angles, they are 90 degrees. And so these are now over constrained. You can undo these dimensions. And next thing is that we have to draw the centers of the next tubes, next 4 tubes at 11 millimeters. So you can draw the circle of diameter 11, and it would split the geometry at these locations. And so just trim away the remaining parts or extra parts which are not required here in this way, and also here, here, and here. So these points, these points will serve as the center for the next geometry. So it's not going to be diameter, but it's going to be radius. So okay, make the correction. So 11 means 22, diameter will be 22. So radius, if radius 11 millimeters, so diameter would be equal to 22. So 22 here. And now trim away the extra parts. And now draw 4 circles of diameter 5.8. And this is a very good thing that Spaceclaim will try to create the geometry based on the previous case. So I'm just making this one line which I missed in the previous attempt. So again I'm repeating with the circles. And so this is a very good thing about the Spaceclaim, that it will remember your last choice, and there's no need to give dimensions again. So it will give you the dimension of the last part, which is a 5.8. Okay. And now you can also trim away these lines because these are not required here. We just need the 5 circles. And from these 5 circles, we will extrude them, and with extrusion, we will get the 5 tubes in a solid form. And you can also remove this dimension. And also trim away these 2 lines. And now you can click on the end sketching, sketch editing and sketch mode. And now we are with these 5 surfaces, and these surfaces having the diameter equal to, if you click on from the pull command, and if you click on the dimensions, you can get a dimension as 5.8. And if you want to measure distance between the 2 centers, so distance is from this center to this center. It's 11 millimeter. Okay, so now we will enable the left and the right plate, and I will simply extrude these 5 surfaces, these 5 circles. And we will just make them normal, so they will not apply any action on the solid bodies which are on their way, and but we will be making them pass them through these 2 plates, but they are not having any action with them. They are not cutting them, they are not uniting them, so they will be there as it is, as independent entities. So now I would just make the split here on these 2 sides, these 2 planes. So I will create these 2 planes, and I will use the combine command and remove these parts one by one. So the extra length of pipe will be removed automatically. And similarly this pipe. Okay, I think this is already divided into the part. So just select this part and delete it manually. And again use the combine command, and this plane here and this part here, and again in the same way, and here. In a similar way, we will apply the same operation on the right side. So choose any one of the tube and delete the extra part here. So repeat this process for all these 5 tubes. So this is a problem of Spaceclaim, that this will not select them automatically after the one operation, and we have to collect them manually one by one. But it doesn't matter here. Okay, so we are done with this operation here, and now I'm going to delete these 2 planes from the screen, and again I will use a combined operation. This time I will use a plate and these 5 tubes one by one as the cutters, and I will remove the part from the inside. So see what will happen here. We will have I will show you at the end of this process. And so just repeat this process now with the second tube and remove the extra part here. Now keep on doing this process. And this time this pipe, and then remove this part from here. Again the plate, and this last pipe, this last tube, and then the remaining part of the tube inside this plate. And then repeat the same process on the other side. So exactly same procedure. And then remove the extra part here. And this pipe. Okay. So if I hide these 5 solid bodies as the 5 tubes, now you can see that we have this thing with us. So now they have the opening for these 5 tubes, and now again I am going to make the one more thing is that I think we first we have to make the thickness of the tube. So once we apply the operation, this will be through all the plates, all the systems like the shell and the left and the right header. But anyhow, this will just add the one additional step. So instead of applying the operation on the tube, so apply the operation on the thickness, because the tube is inside the part of that thickness. So this will be automatically taken care. But nonetheless, because we already applied this operation, so I will not undo this operation, but I will continue with the thickness now. And now choose this plane here and click on the plane view, and this time we are going to create 5 circles again. This time they are going to be at the diameter of 6.7. As you can see here, 6.7, and also in this figure 6.7. So 6.7, and just confirm the dimension again. So 6.7, yes. And in the same procedure, in the same way, create these 4 remaining parts thicknesses over here. Okay, so we have created these 2 circuits again, one at the 5.8 millimeter, second is 6.7 millimeter, which is the thickness of tube. And so before ending the sketch mode, I would be deleting the extra parts here, extra curves here. These are here. So these all curves which are used for the construction purposes are going to be deleted, and also these small lines here which are in between the thickness. Okay, now we can end the sketch mode here, and also we will be deleting this dimension, and now end sketch mode, and also delete these internal circles from here. And now this is the fact that we can use only this geometry to create the thickness and as well as these tubes. So anyhow, again we will repeat the same procedure, and we will use the pull command, and the option will be selected as a no merge. So this no merge means this will not interact with any existing geometry in this way. And now I can use the combine command and delete these extra parts from here. So you can use the different methods. For example, we can use a plane, we can use the body itself. So this pipe and this body. So just hide these solid bodies here, and I want to confirm them one by one. So delete this body. Okay, all right. So I think instead of doing that thing, we need to create the surfaces, these two planes on these two sides. Okay, all right. So I would be creating the two planes, one over here and second over here. And I will repeat the same procedure that we did in the tubes case, and I will remove extra parts from them, and this will not be shown in the video. And after applying the combine command, now you can see that we have these 5 tubes, and also we have thickness of these 5 tubes, and dimensions are 5.8 millimeter for this internal part of the tube, and the thickness has a diameter of 6.7 millimeter. And now we'll apply this operation on the left and the right pipe system. These are the header system. So we'll apply this operation on these two solid bodies. And for that we will go to the option or the menu as the prepare. And here we have the option for the imprint. And you can see that we have these lines, they are ready to be imprinted on these surfaces. So just apply here, and this is done now. And after that we will hide these thickness parts from the tubes. So just separate them, just hide them. Okay. So just keep the tubes here, just keep the tube, these 5 tubes here. You can see we have just these 5 tubes with us, and now we will simply combine them. We simply combine them. For combining, the operation is same, that is a combine command, but for the combining means to join them, we have to press the control key while we select these bodies. So instead of using the one body and then cutter, just use the control key. Just hold down your control key. So press the first, then press the control key. So you can see this option is enabled, and this option is used to merge the bodies or to combine the body. That is to unite these all bodies. So first, second, third, again repeat the same process for the remaining tubes. So these 5 tubes and this header, they are connected, and now they are forming the single body, you can see. And now simply I will use the same command, same combine command, and I will again press and hold the control key and use this last part and to combine them into single part. So now this whole body will join them, will be the single body, and this is the overall pipe or this tube and header system here. And from this side the flow will go inside, and from the flow here, from this side the flow will go out. So this is done. Now remaining thing is that we have to apply this operation on the shell side. So either we can use this operation before or after. So anyhow, because this is the separate part, so just hide this part here. This 1 minute. So still they are not joined. So now they are the single part. So I can rename them, and I can put them name as a header and tubes. Okay, and now just display the shell part and these 5 thickness parts, these 5 thicknesses of the pipe. And now we are going to apply the combine command, and this time we will use the subtract option and just subtract the inner part, and then repeat the same procedure for the another tube, another thickness part, and just delete the internal part, which is the we are subtracting this tube, this thickness from the shell side. This will make the holes inside the shell, and around which the flow of the fluid inside the shell will flow around these surfaces, and they will also make the heat transfer surfaces with respect to these thicknesses. And from this thickness, the heat transfer will go inside the fluid of which is flowing inside the tubes. And now apply same operation here and repeat the process. Okay, so I just want to see that what is happening here, so I can hide these parts one by one. So now we have the opening in these are 2 openings we have here, and okay, so we can undo this one. So I think there's some mistake here, so we will do it one by one. So we have the shell part, this should be there. Okay, so we start with the 1 tube here first, and use the combine operation and delete this part. So now you can see that we have this shell part, and then we have this solid body which is here, and one solid body which is the thickness of the tube. So one is here, second is over here. So you can delete this part here. Okay, so again display the another tube here and use the same operation, that is a combine command, and delete this part here. And you can see that if I hide this part, you can see with the extra pipe inside, and then we can delete. And again hide this part, and then go with the another part and also display shell body here, and use combine command and delete extra parts which are here. So in one go we can also delete them. And again you can So the shell body is here. This is a solid body here, and so this is already done here. So we can use this body, and again the combine command, and delete these bodies. And the last body is here. So again the use of combine command, and this time we use the last thickness of the tube, and inside and also outside they should be deleted in a one go. Okay, so now I will put in the name as for this one as again the shell, and then for these parts you can rename them as the thickness 1, for example, and you can move them upward. You can move the shell on the top side, and second one, and you can put the name as a thickness 2, thickness 3, and up to thickness number 5. Alright, so we are done with these the naming of these 5 parts, and now we can display these all parts in a one go. And so we have the different volumes, and these two plates, they will not play any role in the CFD analysis, so you have to just create the interfaces, and maybe we need to split these surfaces for making the proper interfaces in between these sides. But at the moment they are almost done for the CFD analysis. They have the separate volumes. One is this volume for this tube. So you can see that we have the one is the shell part, and one is this header part, and then we have these thicknesses. They will be used for as an interface between the shell and this tube. Then these thicknesses and the tubes which are inside this header system. So there will be two interfaces. One is on the shell side, one will be on the tube side.